Hi and hello. Welcome to the lecture series of Multiplexer. So myself M.Naveenraj, Assistant Professor, Department of CSE IoT. So today's topic is a multiplexer. Normally in communication, so there are n number of signals will be transmitted through a single path. Finally, in the output, all the signals will be received and remove the noises and then sent to the destination, so particular destination. Okay, so here the multiplexer is nothing but many to one inputs, so many inputs but single output. This is called multiplexer. So in terms of definition, it is a circuit used to select and route any one of the several input signals to a signal output. So in a single path, if there are so many inputs are available, so many inputs there are, it may be 8 or 4, 16, 32, 64, n number of inputs, but you have to select only one signal at a time and then transmit it to the output. So this is the concept of multiplexer. So you can see here the example is a simple example of non-electronic circuit of multiplexer is a single pole multi-position switch. So we have a multiple positions, but you have only one single pole. That type of switch is a best example for this multiplexer. Okay, so here look at the diagram, pin diagram. So here then input signals are given to the multiplexer as an input. Then in the output side you are selecting only one signal. So with the help of this control lines, that is selection lines, you are going to select which input to be was transmitted through a multiplexer and received in the output signal. So understanding 4:1 multiplexer. Now we already said that multiplexer will have many inputs and single output, but here we are taking the example of 4 input and 1 output, that is 4:1 multiplexer. So here the 4:1 multiplexer has 4 input bits and 1 output bits. This control bit will be selected from the 2 control bits. Okay, so the 4 input bits are D0, D1, D2 and D3. Okay, let us take an example of D0, D1, D2, D3 are the 4 input names. Only one of these transmitted to the output Y. So the output depends on the value of AB, that is control bits. Control bits are 2 control bits, so A and B. So based on those combination, we are going to select any one input and transmit it to the output. The control input determines which of the input data is transmitted to the output. So there are so many signals are waiting, but this control signal only has a ability to decide which input to be selected to the output. For instance, as shown in the figure, when AB equal to 0, 0, 0, that means a two control bits, that both control bits are 0, 0. The upper AND gate is enabled while other AND gates are disabled. Therefore, the data bit D0 is transmitted. The first input will be transmitted to the output. So look at this diagram. So here you have 4 inputs D0, D1, D2, D3, and the 2 control bits are A and B. The 2 control bits are connected with a NOT gate in order to take the reverse, that is not input of A and not input of B. That is A is A bar, B is B bar. So that will be selected based on the input. So this is the 4:1 multiplexer with 4 inputs, 1 output and 2 selection lines. Here we have used AND gate and OR gate. So for first condition, if the control input is changed to AB equal to 1, 1, okay, all the gates are disabled except the bottom AND gate. So in this case, D3 is transmitted to the output. So likewise, based on A, B input, the input based on the inputs of A and B, the data D0, D1, D2, D3, whichever is eligible for transmitting to the output will be selected. For example, in terms of 4:1 multiplexer, the IC is 74153. This IC is manufactured with 4:1 multiplexer. So in laboratory, you just buy this IC and plug in a breadboard and give the input, and you can select the output. So based on the control lines you are giving, A B is 0 0 means first input will be selected. Here look at this diagram once again. AB is 0 0. If you give the both inputs 0 0, the first input D0 will be selected and given to the Y through OR gate. Similarly, if AB is 0 1, second AND gate will be on, so the D1 input will be selected and transmitted to the output Y through OR gate. Similarly, AB is 1 0, the D2 output will be selected and transmitted to the output. Similarly, AB is 1 1, the last AND gate, that is bottom AND gate, is selected and D3 input will be transmitted to the output. Okay.